Joining us here. This is the, I don't know, by now, sixth or seventh edition of our Center for Macro London workshop, which is basically a venue where researchers from the Center for Macro and associated institutions and nearby present work in progress roughly every term. So this is a mix of a conference insofar as, we have papers submitted and we selected some, but very importantly, it's really a work in progress workshop for us to discuss research that's kind of people are developing, as well as to develop a little bit of a community among Center for Macro and around researchers to chat about research regularly. So very happy to have you here. The ground rules are going to be that each paper is 45 minutes. The first 10 minutes we don't interrupt, so the person can make sure they make it to the end of the introduction and say what they're going to do. Afterwards, feel free to unmute yourself and interrupt, as in regular seminars, I guess, over the last few months. And then I'll warn the speaker when we're 5 minutes at the end, or when he or she has 5 minutes left. But for now, what a better way to start than with Pedro telling us about vertical mismatch. So please go ahead, Pedro. Thank you.
Thank you. So this is joint work with Pedro and Teptida. Pedro is online, so he can potentially answer questions on the chat. And this paper is about mismatching the labor market. Now, if you go to the most popular textbooks in labor economics, so undergraduate textbooks, and you won't find a dedicated chapter on mismatch or a model of mismatch. And this might give you the impression that it's, one, not important, or two, not studied by economists, but this is false on both accounts. So actually, mismatch denotes a very general class of problems where two sides need to match along some dimension, but do so incorrectly. And there's many dimensions of mismatch. One of it, and the main focus on the paper, is what we call vertical mismatch, when the dimension you need to match is along some quality. So there's some ranking. So you can either talk about education mismatch or skills mismatch when you define skills as ranking, high skills, low skills. And this is very important for policymakers. So if you go, there's OECD or European Commission are particularly interested in this topic. And you have workers that are employed in occupations that typically require a different set of educations or skills. So in this context of vertical mismatch, some workers might be defined as underemployed when they are working in occupations that require low level of education. Sometimes in the literature, there's a lot of different words to describe the same phenomenon. So over-education, over-qualification, over-skilled. On the other hand, you have the case of overemployed workers, workers with low education or low skills working in high skills or occupations that are majority done by people with high qualifications. Okay, now there are other types of mismatch that I won't talk about. You can think about horizontal mismatch when there's no natural order. So mismatch of college majors, occupational mismatch, or even skill mismatch when you define skill as, let's say, numerical versus social skills. There's also unemployment mismatch, so mismatch between unemployment and vacancies. And some people actually called education mismatch, the mismatch between the skill of the worker and the education they get in the context of an endogenous choice of education. So I just want to set the definitions or these different problems because I'll focus specifically on this, we'll focus on the vertical mismatch. So I want to give you some examples of the phenomena that we want to that we'll be talking about. So let's go to 4-digit occupations in the US, very fine occupations. Let's see, for example, waiters and waitresses. And what we see is that in 1970, 5% had a college degree. And now 20% of waiters and waitresses have a college degree, at least 2 years of college. And the college premium, there is a college premium in these occupations of about 25%. For waiters and waitresses. But this is just one example among many. Hairdressers, the college share has increased from 3 to 18%, door-to-door sales worker, news and street vendors from 5 to 30%, taxi drivers, chauffeurs, telephone operators from 8 to 25%. So 1/4 of taxi drivers have college degree. These are examples of what we will call, if we were focusing on education as this dimension, we would call them underemployed. And there is a college premium of being underemployed that range between 60 to 30%. Now, the other side is overemployed. So when we start flying again, you might not want to forget this, but about 17% of aircraft pilots or flight engineers today don't have a college degree. And in the 70s, it was more, it was 48, but still today is 17%. In the 70s, they earn 10% less than their colleagues that had college degree. Now they earn 40% less. And you go to other, what we can think of skilled occupations, agriculture, food scientists, the share of no college degrees from 40 to 0. If you read The Economist, they will mention many times the interior designer, that there's restrictions to become interior designer, you need a degree. So the share of no college degrees from 60 to 30%. Managers in marketing, advertising, public relations, nurses, etc. So these are examples of what we call overemployed, and there is this wage penalty. About 12 to 40%. Now, I want just to set one thing clear. This is not a normative paper, and there's no normative judgment about whether this is good or bad. It's not about that. The paper is about the positive implications of this. So this is sizable, and we just want to, it's not to explain this, we want to see the implications of this when we look at, for example, the college premium or output. Okay, so what we do, we propose a textbook model of vertical mismatch. So it's a simple neoclassical model. It's a very, very simple model just to get, just to start, well, to think about these different aggregates. So a different partition. And that there is an advantage of this very simple model relative to other more complex models that use search or other more complicated models. So it's an insight that we captured, I think, very, very particularly well. And it's this insight that wage differentials are key determinants of mismatch. So the wage difference between skilled and unskilled occupations is an important determinant of mismatch. If the wage difference is very large, few people would decide to be underemployed. But on the other hand, there's a reverse causality from mismatch to wages. So the fact that you have a substantial number of people with college that are actually working in unskilled occupations has an implication for the wages, both on top and at the bottom. And this endogeneity, so in our model, underemployment, overemployment, and the wage differentials everything is going to be jointly determined. And I think this insight we capture very well with this model. So just think about this. You restrict low types access to skilled jobs, like The Economist, when they say you need to have a degree to be an interior designer. Then in the model, there's going to be an impact both on skilled wages and unskilled wages. And as skilled wages go up and unskilled wages go down because you are restricting access to these jobs, then it's going to deter underemployment. So the idea is that everything is going to be jointly determined. Now, what we do, we really want to model just to think about and analyze macroeconomic consequences or implications of mismatch. And we are going to focus on two literatures. One is a macro literature on the Tinbergen's race. So the race between education and skill bias technological progress to explain the evolution of the college premium in the US. And we want to understand how mismatch or how these presence of underemployment and overemployment affects our, we are going to reinterpret this Tinbergen race and considering the role of mismatch. And the second literature or the second application is one that attracted a lot of interest from policymakers. And it's what are the output costs of vertical mismatch? Is it large or is it sizable or it's not? So we'll think both of educational mismatch as we defined just before, but we'll also have an example with skill mismatch. When we don't define, our types won't be defined by the college or no college, but by actual measures of skill. And this is going to be a cross-country exercise. So we want to understand cross-country differences in output costs of vertical mismatch. So this is the idea. I'll just jump on the literature and I'll start. So if there are any questions now, I don't know if it's been 10 minutes, but
we've hit the 10 minutes. It was perfect timing. I had a question. So when you hear the word mismatch, by literally the word miss, it means that, well, this is deviation from first best. Are we going to be talking about constraint efficiency relative to some information or search frictions? Are we going to be talking about instead some suboptimal outcomes? Because that guides me, at least in terms of what we're trying to show here.
Yeah, no. So the answer is no. And so we call it mismatch because most of the literature, and if you go to policymakers, they call it mismatch. And it's a positive paper, so we won't be talking. You'll see we'll have a source, we'll see how we motivate, but we can't talk about efficiency. We won't talk about efficiency. It's really more about the implications of this. So when we think about the evolution of the college premium, if you have, and you'll see 1/3 of college workers that are working in unskilled occupations, how can we rethink this Tinbergen's race in light of this model? So that's a very important point. It does bring to mind, and I think a lot of people think, oh, this shouldn't happen. But we are not going to talk about, and the model can't talk about this. It's really about the positive implication. What are the consequences of this? And that's what.
So then it could be called a model of matching, not of mismatching. Is what you're saying? There's going to be some matching going on.
Yes, we could. Yeah. Okay. It's hard. So I do think it's the lack of a textbook model that we use the word mismatch for a very different class of problems. Yeah. Okay, so this would be the standard theory that we find when you have two types of workers, that you find in any textbook. So you have workers that are of high type, and these are fraction n, and 1 - n workers of low type. And this is the words that we'll use now to classify the workers, high type and low type. And then in the empirical applications, we can talk about educational mismatch or skill mismatch, depending on how we match the model, how we map the model to the data. And we have jobs, skilled jobs, unskilled jobs. Now, usually there's a one-to-one mapping, and we just say skilled workers do skilled jobs. And that makes us, we don't have to be very careful in the language. So we associate the skilled job with skilled worker, educated worker, skilled job. There's no really distinction because there's a one-to-one mapping. Now, when you think about what we call mismatch, it's in the possibility set. It's in your possibility. If I am of high type, I can do unskilled jobs. And when I was younger, I worked serving breakfast in the hotel in Vondelpark in Amsterdam, and I can still do it. And so it's a choice. I can do it. If I am, I would be denoted as underemployed. So you would denote the number of people that are working in this unskilled occupation, and zeta denotes my efficiency units relative to some low type worker without in that occupation. So zeta would tell what are my efficiency units in the unskilled job. Now,
Pedro, can I just ask? It's kind of related. If you think about 1970 and today, are we thinking that the college-educated people are the same in 1970 and today? I mean, there's also a lot of evidence that college graduates today are like lower types than 30 years ago, for example.
Yeah. So no, so that's a good point. So it relates to some, if you think some unobserved heterogeneity, and so that's you'll see one of the striking facts that I'll show later when we go to the data is that actually the share of underemployed out of college hasn't declined. You know, the share is the same. It's 1/3. 1/3 of all college graduates, whether it was in the 70s, 80s, 90s, and now, 1/3 are underemployed. And this is constant. So if that story was a big driver, then we would expect that underemployment as a share of college would go up. But it suddenly, so we can discuss a little bit the implications of that. So it wouldn't matter for our first exercise. It could matter for our second exercise when we compute the output costs. So that I can mention that a bit later, but it's true. So there is this fact that you know, it makes us think that it's not the main, it's not so important.
No, but the data you showed was like within the occupations.
Yeah, no.
So if as a share of college graduates underemployed went up, then across all occupations, the share of college graduates must have gone up. So
yeah. No, but that's it. The share over college hasn't gone up. That's been constant. But I'll show the data. That was just some examples. So you'd see sizable. But I'll show the data, the overall, the aggregate data. And so, why vertical mismatch is different from horizontal mismatch is that the problems are not symmetric. And if you think about, I could still serve breakfast in the hotel, but not everyone without college could do some occupations that are skilled. So what we say, it's a fraction theta of workers of low type. Only a fraction theta will have an opportunity or will be able to perform a skilled job. If they would be overemployed. They would be the pilots, and but they'll have different efficiency units. They won't do as well as if their peers that are of high type. So the asymmetry of the problem is this: there is some restriction. Not everyone, not all the low types can do skilled jobs, and the asymmetry is in the efficiency unit. So high types in unskilled jobs would be doing better, at least as good as, and the low types in skilled jobs won't be as good as high types. Okay, so this is the setting. The technology would be a production function. I wrote here general production function. In one example, we will have a CES. In another one, we'll have a Cobb-Douglas. But this, so now we have to be careful. This defines the age and GL, the number of skilled and unskilled jobs. Okay, and the difference for a traditional model is the traditional model, you match the jobs to M, to the fraction of high type. But now the jobs in efficiency units of high type is workers of high type, sorry, minus the ones that are underemployed because they are the waiters, plus the overemployed weighted by their efficiency units. And the jobs of unskilled jobs would be workers without college, so of low type, minus the ones that are overemployed, plus the underemployed workers with their efficiency units. Okay. Okay. Now, when we give the option of workers to choose between two types of jobs, or if you want two types of occupations, then we have a problem of sorting, or if you want an occupational choice. Okay, so the typical way in which we think about it is with a Roy model. This won't be exactly the typical Roy model; it will be a variation. So what we think is that there is an idiosyncratic cost to perform or access these jobs. And this is a shortcut for any possible barrier or friction that prevents workers from accepting the highest paying job. So this could be, you know, maybe the good job, you have a 3-hour commute, or you have to change, you know, sell your house and buy a new one. Maybe you have a preference for, you know, to be in the hotel. It can be really anything. And that's why we can't talk about efficiency or because we don't take a stance on what's really the source of mismatch. There will be one barrier, some barriers. So the utility of the worker is going to be the wage in a particular occupation will be the wage minus the costs. And this new gives the weight of the cost. So think about this as the size of the possible frictions or the possible barriers. As nu goes to 0, then the worker is going to select the highest paying job. Now this epsilon is going to be a standard Gumbel distribution. So this is extreme type 2 error distribution. So this is actually the same problem as the multinomial logic model from econometrics. Okay. It's this, so it's because we don't take a stance on what's propelling, what are these costs, then we can't talk about efficiency. Okay, so if you are of high type, then you have two options. Either you'll be well matched and you get WH, and this will be idiosyncratic to each worker, or you'll be underemployed and you get WL multiplied by zeta, by the efficiency units. So, so because of the function, the distributional assumptions, this is the expression for the underemployed. So what this makes is the underemployment is going to be a continuous function, and it's going to depend on wage differentials. So if everything else equal, if the wage gap between the well-matched worker and being underemployed is very, very large, then few people want to be underemployed. If the differences are not very large, then you'll have a higher fraction would be underemployed because the wage cost of underemployment is not that large. So if you think about at the limit, if they pay the same wages, then it's a coin toss. Half would go to one and half would go to other if they pay the same wages. But what this puts is emphasis on wage differentials as a determinant of underemployment. So we don't know whatever barriers there are, but we know that if the wage differentials is high, people are going to overcome those barriers because if the skilled job pays 3 times more, they'll commute for 2 hours. Okay, so that's the idea. And nu is an important parameter because as nu goes to 0, then you'll always choose the highest paying job. And if it's the skilled job, then underemployment is 0. So we can encompass the regular model. Now for the low type, not everyone has an opportunity as the skilled job. If they do have an opportunity, then you can either decide to stick to your unskilled job, WL, or you'll be overemployed and you get chi times WH. And then this is the expression for overemployment that has here the theta, because it's only if you have an opportunity to this skilled job that, and out of those, then people would choose, again, depending on wage differentials. Actually, when you go to the data, you are paid more if you are overemployed. So if you do have a choice, the majority would go to overemployment because they pay higher wages. But then, so the restriction here is important. And then finally, the wages are just equal to the marginal productivity. So each worker is paid its marginal productivity. So the wage of high type is equal to the marginal product of labor, but it's all in efficiency units. So we have 4 types of wages: the wage of a well-matched high type, the wage of a well-matched low type, a wage of an underemployed, and a wage of overemployed. Okay, and these are very easy to map to the data, so to back out from the data. So this is it. So I don't think you can get any simpler model than this. It's just to show you the solution to the model is just putting the wages in the equation for underemployment and overemployment, and the wages depend on the market, on the supply of skilled and unskilled jobs, so depend on U and O. So then you have 2 equations to 2 unknowns, and this is in the case of Cobb-Douglas, we can prove the existence and uniqueness. So potentially there could be, you could think about multiple equilibria. So suppose that there's a lot of overemployed. So you could think it doesn't exist in the Cobb-Douglas. And when we look at the CES, we always verify numerically that it doesn't exist. But I think if the production function that was a very strong complements, that might exist multiple equilibria.
Sorry,
okay.
Pedro, can I ask you a question?
Sure.
So here, basically, if I understand correctly, you're building your heterogeneity in the preferences in the epsilon. And I guess an alternative way to think about the data would be to think about heterogeneity in the chi or in the O parameter. So I choose to be underemployed if I am particularly good at the low skill occupation and the other way around. So is there kind of anything in the data that can
yes, so that's a very good point. So the typical ROI model would have that. No, you have different efficiency units in different occupation, and you always select the highest wage. And now we think this is more consistent with the view of policymakers. And when you go to detailed surveys, people do say they are not well matched. And but the short answer to your question is, for the first exercise that we are going to do, this exercise on Tinbergen's race, it doesn't matter. It doesn't matter the cause of the sorting, because what we'll be looking at is the evolution of the different aggregates. So the efficient units would be captured when we match to the data. So this chi and this zeta. It will matter for the second exercise, which is the output costs of mismatch. And if it was your model, then the output costs would always, you couldn't do any better. If we took out mismatch, output would have to go down, because they would always be employed in the place where they have the highest marginal productivity. So their contribution to the economy would always be the highest. So if we had done that, the second part of, second exercise wouldn't make so much sense. But it's important. So I can talk a little bit about the conclusion on that. I think our model is more realistic, but we can talk about that afterwards. But still, at least for the first part, for this Tinbergen's race, it wouldn't matter. So
Pedro,
what is
Pedro, can I ask you?
Yeah.
A quick related question. So do you also have a way, well, I guess not in the model, but in the data, to sort of keep track of experience on the job, in the sense that, like, presumably the skilled guy will pick it up quicker, but it's not obvious the first day on the job it will be more productive than the unskilled guy that's been doing that for years or something, right?
Yeah, so that the literature on mismatch, and there's a big empirical literature looking at PIAC, and they would have this type of, they would analyze who are these mismatch workers and the characteristics. But here we are really interested more on the macro implications. The idea is that we match, we think about their marginal productivities and their efficiency units. It's mapping to the data on wages. So we don't go further than that, because we want to give a step back. The literature has been more kind of micro applied, and we want to think about the macroeconomic implications of that. So that was an area that we didn't look much. So if we come back, so we have a production. So we are going to follow Acemoglu and Daughter, the handbook chapter, very, very, very closely. And we start with the CES, with factor augmenting technologies and an elasticity of substitution. We can calculate the college premium, so the wages, WH and WL, and this would be the expression. And this is the key equation in the model. It's the same for us, but now how we map to the data is different. So the difference is that we should measure GH and GL not as the percentage of college workers over the non-college workers, but we should account for mismatch. So take out, from the skilled jobs, take out the underemployed and add the overemployed multiplied by their efficiency units. So this is one difference on how we measure the quantities. So we have to adjust for mismatch. And then the second is that the college premium should be measured only for the well-matched workers, because it's going to be different for mismatched workers. Okay. So we go to census IPUM's data. So this is 70s, 80s, 90s, and annually from 2000 to 2017. And we are going to define these 4 groups the way we thought about them before. We do have to be there's an issue of how we think about each occupation, what is skilled and unskilled occupation. So what we do is we go to 2017, the latest year of the data, and we see which occupations are majority college workers, and we define them as skilled occupations. And then we fix these occupations back in time. Okay, this is one way to do it. So the model is very simple, and once we have 5 targets, we can back out the 5 remaining parameters. So the N, you can just, what's the fraction of people with college, and then all the other 5 parameters you match to 5 moments of the data, which are the quantities, underemployment and overemployment, and the relative wages from these groups.
Pedro, on the objective measure, now you do this in data, is this either if I deviate above or below or not, or you're just looking at above?
No, because you also have the overemployed. So you say we go to 2017, we have 458 4-digit occupations. We check, we rank them by the percentage of college, and we insert a cutoff. If you are above, you are called a skilled occupation. If you are below, you are unskilled occupation. And this cutoff, these occupations stay the same when we go back in the 70s. So there is 5% of occupations that in the 70s, they were majority no college, and they switched. But we fixed them at the 2017 level. It's actually very few occupations that switch, only 5%.
So you really only have 2 categories. It's college or no college.
Yeah.
Matching the model, which has the 2 types, right?
Well,
but
so
here,
there's when we see the workers is college, non-college. And the job is skilled and unskilled that you define by the majority of workers there.
Okay, got it. But exactly because of this, I mean, when I compare across time, there's been big changes in what it means to be a factory worker or so on. And it might have been in 1970 just doing some mechanical thing. Now it may be operating the machines, meaning within industries, within occupation, we've seen big changes. So you are keeping that fixed. Is that correct? But
yes.
How do I think about that? I mean, because that should introduce, if you do 2017 versus 1970, first of all, maybe I'm wrong. When I look at that question, are there very large changes in that there's lots of occupations in 2017 are much more, because we know there's a trend up in college education to start with. So there has to be at least a trend up here.
Yeah. So when we go to the 4-digit occupations, so what I can tell you is that only 5% of these occupations would actually switch. So if I had done this exercise in the 70s, there will be 5% of these occupations that I now call them skilled, then I would be calling them unskilled. Only 5%. So it's not, so if you see the cab drivers, the waiters, the hairdressers.
But if the occupations haven't changed, Pedro, we all know that share of college has increased quite a lot. If the occupations haven't changed, it means that among the college, among the high skill occupations, there's very few mismatched ones now, because just on account, imagine the trend would happen. And among the unskilled occupations, all of a sudden you'll see a lot more mismatch. You see what I mean? There's just a mechanical trend that says there's going to be increasing.
So that's definitely, so that definitely plays a part, and I'll see you exactly how much of the change in education accounts for the change in underemployment. But then you can think about the other way. So if there's skill bias technological progress, and these skilled, these occupations, the returns are so high, then you would also expect, why would someone want to be waiter now, that the wage differentials are much larger? So you also have a kind of Tinbergen's race on the underemployment. And you'll see
conceptually that these races. My only issue is just that the way you're defining it on the measurement, you will just on account of the trend in education, you'll always find an increase in mismatch among the low skilled ones and a fall in mismatch in the high skill occupations, just because of the trend in college education. And I'm just trying to understand, is this a problem for the quantitative results or not?
No.
This is independent of what's driving what.
Yeah, no, so we can look at the data now. So so you see the increasing fraction of people in college, and you see this downward path on overemployment and underemployment. Now this is as a percentage of total. Now, what's more interesting, if you divide them by the relative, out of all no college, how many are overemployed, and out of all with college, how many are underemployed. And this is one of the surprising features that we find, is that actually this varies between 0.32 and 36. So it's really 1/3, whether it was in the 70s or now, it's always 1/3 of people with college are ending up in this unskilled occupations. And it's about 15%. So here you do also find a slight decline as a share as well, but it's about 15%. So I do think this is quite remarkable that we are producing we are making students coming out with college, but 1/3 of them are going to end up in unskilled occupations. So I think then it's So if 1/3 are going down, then naturally underemployment is increasing just because of the share of college has increased. And these so I have 7 minutes, so I'll just go quickly. So then we have here the different wages, and the wage. I'll just the graph on the left. This is the wage of a well-matched college relative to underemployed. So this turns out to be one very important variable, which you can think about the wage cost of underemployment. So if you are relative to an underemployment, if you are well matched, you earn 90% less. So this is the wage that underemployed workers are sacrificing, 90%. That's why I think that idea of the efficiency units, maybe you are more efficient as a waiter. It means that you would have to be almost half your efficiency units to prefer to be a worker had to be half of an average college worker well matched for you to actually prefer to be underemployed. So that's why I don't think that story is really the key driver. Now we follow Asimov and Otter, and we have to re-estimate the elasticity of substitution. So we can't use the same. And we do what they do, which is a regression of the log of the college premium on the log of the relative supply of skills. But we can put here the two series, the one that's not adjusted by mismatch and the one that's adjusted by mismatch. And here, if we don't adjust, the relative supply of skills increased by 3 times. And this is what all sparked this literature, that the college premium has been increasing a lot, but the relative supply of skills, has increased 3-fold. But when we correct for mismatch, the increase is only 60%. Why? Because back then you had pilots. They didn't have college, but they were pilots. And today you have a lot of people with college, but they are waiters. And actually they are better. Because they are better than the waiter with no college, it means that you increase the denominator a lot in efficiency units. You are increasing a lot the denominator, and you also have a difference in how you measure the college premium, because now you should measure it as in only for the well matched. So we do the regressions. We find that the elasticity of substitution is much lower, so much closer to a Cobb-Douglas. Then when you don't adjust, that's the elasticity of substitution of 2. And then we can back out all the parameters, and we can do a decomposition exercise, and this will be the last thing I'll show. So this is the variation of each of the variables from the 70s to 2017. And particularly the college premium. So this is the average college premium, what people have done in the literature. So the college premium went up by 40 percentage points. And now we can do different counterfactuals, which are, what if we just change the skill bias technological progress? What if we change the education? And we see this Tinbergen's race. The skill bias technological progress push the college premium up, and the education pushes down. But now we can see what accounts the different efficiency units of different types of workers. It accounts 15 percentage points. And the other 2 parameters, also 15 percentage points. So let's say the theta is when you are restricting the skilled occupations, you are restricting the access. So that means that you have fewer overemployed. So they are, they go to unskilled jobs, they will push the wages down, and there are few in the skilled jobs, and that pushes the wages up. And the same so the mismatch, it has been increasing. So if you have more mismatch, you have fewer underemployed, you have more underemployed people, so then the wages. So when we put together, we see that these 4 parameters related to mismatch account for as much as the skill bias technological progress. And the last thing is we can also decompose the change in underemployment. And you can see that just the fact that we have more college workers is increasing a lot underemployment, more than 100%. But this has been counteracted by skill bias technological progress. And the increase in mismatch. So there has been an increase in the barriers, in the frictions, and that also pushes the underemployment up. Okay. So we can do this for all the variables. Now, I didn't have time to go on the output costs of mismatch, but this is a cross-country exercise. And I'll just conclude. Sorry, and so I don't conclude on what I've said. I'll conclude on the part I didn't mention on the cross-country results. That if you eliminate education or skill mismatch, the gains on output on average would be around 3%, but they vary a lot across country, and it's between -1.5 to 9%. And it turns out that the key variable to explain the output costs of mismatch is not the size of mismatch, but it's the wage loss of underemployment. So it's that variable that tells you how damaging is underemployment is also the key variable. And this varies a lot across countries. So it varies from 20 percentage points to 90 percentage points. And this is the variable that really that's really important. And I'll stop here, and we have just one minute for questions.
I mean, I can't resist asking the questions. I mean, your 4th bullet point there, eliminating would raise output. I mean, what do you mean eliminating? You mean change the technological parameter? I forget what that was.
So it's just setting. What if in this setting we set U and O to 0? We can do it in different ways, but it's just let's say, because in a way that's what policymakers have in mind.
No, but what do you mean setting it to 0? Those are endogenous variables, no? The U and O.
Yes.
What's the equivalent? That's setting that phi, or I forget.
No, so it would be it would be new to 0. So we could do it by changing parameters or changing the variables. We think that the exercise would be more understandable if we just set, imagine outright setting U and O.
I don't know what I mean, but you set those guys to 0,
yeah.
But then you stop the economy from running, because if the economy ran, then you'd go back to the previous equilibrium.
So so if you want to get that by changing parameters, you would have to set theta to 0. So you forbid anyone without college to access.
You allocate them, you build them, and then you, I see, and then you stop.
And new to 0. So you need.
Okay, just so I understand what that means. Okay.
Yeah. Okay, so.
Terrific. Thank you so much. And we move right straight